I will start also the. Please. You can continue, Christina.
Great. Yes, thank you. So, welcome everyone to this webinar and this workshop named Climate Change Impacts on Catchments and Food Production. So this is a part of the online conference, the Baltic Sea Regional Online Conference on Water Management in Agricultural Landscapes. And this is the last, I think it's the last workshop for this year at least, in this series. So today we will talk about climate change and impacts on catchments and food production. And my name is Christina Johansson, and I work at the County Administrative Board in Västmanland and the project Life IP Rich Waters. And Life IP Rich Waters is a EU project with over 30 partners, and we are working in Sweden, the northern Vapesi district, with a lot of different projects to improve the water quality. So we are arranging this webinar then together with WaterDrive. So the aim of today's webinar is to share experiences from different countries around the Baltic Sea about climate change and how that might affect the water management and food production. So in my role in Life IP Rich Waters, I work with developing new projects and thematic coordination. So I also want to take this opportunity to get a bit of feedback and hear from you as well, all the participants, what you see are the biggest challenges in your countries and in your contexts. So today we will have 4 different presentations, and I hope we will also have some time for discussion at the end of the webinar. So to warm up a bit before we go through the program, as I mentioned before, I want you to go to menti.com and use the code you see here on the slide to answer the question which country you're from. So see here now, see myself, to get a bit of an overview. Whoops. Where you are from, all you that are participating. So see Finland, Latvia, Sweden, Russia, Poland, Lithuania, Germany. Nice. It's a good spread of different countries, and you're 18 people that answered that. That's great. Then we will have a lot of different examples and different experience to share, I hope. Great. Thank you so much. So today's program then for the webinar, for the workshop, we will start now with my little introduction, and then we will have a presentation by Tia Pedusar from Stockholm Environment Institute, Tallinn, on the potential impacts of climate change on agricultural water management in Estonia. And we will then move on to a presentation by Tapio Salo from Natural Resources Institute, Finland, about adaptation measures to agricultural drought within Baltic Sea region, a literature study. And we will then have a break, so we all can get up and drink a tea or coffee or catch whatever we need to do. And we will then move on with the presentation from Sara Bergek, Swedish University of Agricultural Science. They will talk about what happens in a future climate with freshwater ecosystem services. And then we will have a presentation from Ainis Lagdins, sorry for my pronunciation, from the Latvia University of Life Science and Technologies. They will talk about the effects of extreme weather conditions on water quality and quantity and quality agriculture areas in Latvia. And then I hope we will have some time then for some discussion, that we will be able to discuss a little bit maybe in small groups and then in bigger groups as well, for about 20 minutes, and then we will close the webinar. And the presentations will be for about 15-20 minutes each, and then we will have 5 to 10 minutes for questions. And if you have any questions, you can just either type them in the chat box, or you can type your name, and then we will let you speak and ask your question. And yeah, don't be afraid to ask questions. Please go ahead, then we can have a even greater exchange and discussions. That's always really interesting to see the different perspectives now when we have gathered from different countries. So I think that's it for me. I will hand over to Tia to present, and I will stop sharing.
Thank you. I try to share my screen now. Well, is it in slide? Is it in slideshow? No, not yet.
It's not in full screen. Yes, now it's.
No, it's full screen.
No, it's.
Yes.
Okay.
Perfect.
Perfect. Good morning, everybody. I am Tia Pedusar, and I work for Stockholm Environment Institute, Tallinn Center. And I'm really delighted today to tell you about climate change and agricultural water management in Estonia. At first, I will briefly outline a picture of our climate, water use, and agriculture. Then I will highlight the changes that have taken place in some climate indicators. After that, I proceed with the changes in air temperature and precipitation. And finally, I try to show what may happen in our agricultural water management due to climate change. My presentation is based on official and national key reports and research works. So, Estonia is situated in the transition zone between continental and maritime climates. The Baltic Sea has a strong effect on our climate. And we have in Estonia 3 distinctive climatic regions: the mainland, the coast, and Western Estonian islands. About 50% of our territory is covered by forest, and about 22% it's wetland. I would say fens, forested swamps, and bogs. And Estonia is a very flat country, but we have a large number of lakes and rivers. The population density is about 30 people per square kilometer, which is nearly 4 times less than European average. Average annual precipitation range is from 550 to 700 millimeters, and the water exploitation index is less than 10%. Still, this is pretty high compared to Baltic countries, other Baltic countries, and northern countries. And the reason is that our power plants use water for cooling. If you look at the graph on the left side, it illustrates very well the water use in Estonia. The main water user, it's the energy sector, which takes more than 85% of renewable water sources. Households and industry, they just consume 6-7%. But if you look at the graph, then you can see that agriculture plus irrigation, their water use is really very small, about 1%. In 2020, the total water use was 861 million cubic meters. And what I want to highlight also that the diffuse agricultural pollution has significant pressure on our water quality of surface waters as well as groundwaters. Agriculture. 22% of our territory is covered by agricultural land, and 22% of this land is organic farming, so that Estonians have enthusiastically adopted organic farming. In Estonia, large farms predominate and the share of young farmers increasing. What is important that significant changes have taken place in agriculture. 30 years ago, animal raising predominated. Now, plant production dominates. And significant changes have taken place also in the structure of plant production. Rye has remained a really niche crop in Estonia by now. Winter form of rapeseed dominates. The proportion of winter barley is increasing. And by now we have become wheat growing and exporting country. Since precipitation exceeds evaporation on our territory, irrigation role is really very low. About 0.03% of agricultural land is irrigated in Estonia. Due to damp climate, there is a predominantly need for drainage, and drainage systems cover 62% of agricultural land in Estonia. Before we look to the future, let's take a look at the past. What has happened to some climate indicators of Estonia? A statistically significant annual trend of mean 2-meter temperature was detected in the period 1951-2000, and the increase was 0.2 to 0.3 centigrade per decade. Also, it is important to emphasize that winter warming has been higher on the mainland and lower near the coast of Estonia. Vegetation period has extended by 21 days in the period 1965-2000, and mainly due to early spring. Freshwater supply in Estonia highly depends on precipitation, but there is extremely high spatial and temporal variability in precipitation records. However, the annual precipitation rise by 10% has been detected in the period 1951-2000, and it has happened mainly during the cold season from November to March. Also, extreme precipitation events have become more frequent and intense in the past. Snow cover has decreased, both mainland and coastal areas. In the past, the river ice cover duration has decreased 9 days per day in the period 1930-2010, and mainly due to later freeze as well as a yearly breakup. And winter river runoff has increased significantly during 1951-2015. But spring flooding on rivers has become a rare event. So in conclusion, significant climate warming has already taken place in recent decades. We can say that snowy and cold winter, it is already the exception or pretty rare event, as well as the spring flooding of rivers in Estonia. So, projected changes in air temperature. The most detailed and comprehensive climate projection for Estonia was undertaken by the Estonian Environment Agency in 2015. And the same projections were used as input for the development of the first Estonian adaptation strategy to climate change. And today, I'm just going to refer to this work. The model ensemble contained 3 models. The resolution was 12 times 12 kilometers, and 2 scenarios were chosen. ASIPI 4.5, which is known as an optimistic scenario, and ASIPI 8.5, which is known as pessimistic scenario. And the reference period with respect to which the changes were calculated was 1971 to 2000. And if you look closer at the table, which is on the left side, the table shows that the year temperature rises the most in spring. But also in winter. And looking at the regional scale, a figure on the right side, it shows the winter mean temperature of climatic regions during the reference period. According to optimistic scenario, figure B, and according to pessimistic scenario, figure C. And what may happen? Most likely, the winter mean temperature on our islands will turn to be persistently above 0 centigrade in the coming decades. While in eastern, and especially in northeastern Estonia, it may happen only in the last quarter of the century. Projected changes in precipitation. Let's have a look at the table on the left side, which shows that the mean precipitation will increase in all seasons, in all combination of scenarios and periods. For positive scenario, the model predicts the highest increase for summer months. Yeah. But according to pessimistic scenario, the biggest increase will take place in spring. And looking at the regional scale, the figure on the right side, in summer, it rains more on the mainland. And the figure at the top right shows that the same pattern should persist in the future. But in winter, the precipitation pattern turns. It rains more on the coast and islands than in East Estonia, and more or less the same pattern persists in the future. But it is possible that we will have only 2 precipitation regions by the end of this century. So, in conclusion, since the year temperature increases, the atmosphere can hold more moisture, and there is more potential for more rainfall. But again, it needs to be mentioned that there is a lot of uncertainty and even controversy in precipitation. So change in precipitation due to climate change is probably one of the most thought-provoking topics. And finally, how climate change could affect agricultural water management in Estonia. So we assume that the year temperature and therefore the length of the vegetarian period will increase and the amount of precipitation will increase. So far, agricultural water use in Estonia, it has been really very small, as we realized, just about 1%. And due to damp climate, we have pretty extensive drainage system, and we haven't had much need for irrigation. Also, we haven't serious need to collect and save water. But it has been discussed that if our agriculture wants to benefit from the climate change, then several needs will rise, which will change the current agricultural water management. Probably need for construct new drainage systems. There will be need for construct new drainage systems and reconstruct older ones. And the need for better maintenance, this is just a really desire and need, very important also. Again, there is a lot of uncertainty in future precipitation pattern, but if winter precipitation will increase and fall as a rain and spring drought becomes more likely, it seems reasonable to think about more active water management options in Estonia, possibly to save and allocate water resources. And for this, we need to construct infrastructure like water reservoirs, pumping stations, channels, and so on. There has also been discussion about the need for irrigation in the future. Climate change will lead not only to extreme rainfall, but also to high temperatures and droughts. The need to build irrigation systems in drought-sensitive fields is thought to be necessary from 2050. The recent model on potatoes in Estonia revealed that both water shortage and surplus reduce the harvest. So it is very likely that irrigation and drainage systems will be equally important in the future in Estonia. It is likely that the need for restoration of water bodies may rise. Warm winters promote nutrient leaching into the lakes and rivers, so the eutrophication of water bodies is further gaining momentum. And we think that the water use for agricultural purposes, probably it will increase. So this was the story I wanted to tell you today. Here is the list of most important references, but definitely this is not complete. And thank you for your attention.
Thank you so much, Tia. Now, we'll see if we have any questions for you in the chat. I see we have a comment here from Kaja Peterson. The runoff of nutrients due to reconstruction of drainage and irrigation systems may increase. Was that more of a comment or something you wanted to elaborate on, Kaja, the person that wrote the comment? But that was only a comment.
Yeah, this is true that it usually happens when you just construct drainage systems or irrigation systems, then yeah, nutrients load may rise. Yeah, that's it.
And we have a hand here from Ainis.
Yes, thank you. Thank you, Tia, for a very good presentation. I can only agree that in Latvia we have similar patterns in terms of temperature, precipitation change, and also change in runoff, especially during the winter time. And since the magnitude of spring floods has decreased in last decades, so then I would like to ask a question. If you also see that expressions of eutrophication in inland waters therefore also increases, because that's what is of concern, at least in Latvia, that we can see more and more evidence of outgrowing plants in different kinds of streams, and those are somewhat related to increased nutrient losses. But on the other hand, we also see that natural cleaning mechanisms that have been in past, they are not taking place now, since we don't have these massive ice amount of ice that is cleaning the streams itself. So do you have also this eutrophication exposures also in Estonia from this point of view?
Yeah, I agree with you. Pretty the same picture in Estonia also, because probably our landscape is quite similar, but at least I think that you have more large rivers than we do have. I don't know how about lakes, because in Estonia we have plenty of very, very small lakes also, so that agricultural activity affects both lakes and rivers very much.
At least we don't have such a studies that would provide a scientific evidence that these exposures of eutrophications are related with increased nutrient losses. And also we don't have any studies that would confirm that also the self-cleaning processes are not taking place. So that's just for discussion, that there's still need for maybe targeted studies to evaluate how these changes affect not only the quality but the quantity of water in the streams, and how these affects these eutrophication exposures. So yeah, thanks.
Maybe the last comment that maybe the self-cleaning doesn't work anymore because the human activity is so high. Okay.
And I see we have another hand here as well, a question.
No, it's actually, I would like to join the discussion if I can, because
yes, go ahead.
I am from Lithuania, and we see the same trends, but how to say, nitrogen loads are increasing in water bodies, but we connected to increasing of use of fertilizer because the intensification of plant grow agriculture is actually happening in our case, and we see tillage of grasslands and more growth of growing of crops, and also climate change does have influence in winter because there is less snow cover and more soil, how to say, leakage. But primary cause for us is actually intensification of agriculture, and I would assume it should be similar trends for Latvia and Estonia, because agriculture during Soviet times was, or after Soviet times, was down, and with EU subsidies it has been increasing maybe as well. I don't know exactly how it is in Latvia and Estonia, but I assume should be similar trends like in Lithuania too. So it's all my comment.
Yeah, we have noticed in Estonia that use of fertilizer, it highly depends on the economic situation. When economic situation in Estonia is bad, then farmers don't have enough money to use fertilizers, and then there is kind of healing moments for the water bodies as well. But again, it's a human activity which just affect the water bodies, surface water bodies very much.
Now I see we have a hand from Katarina.
Yes,
to comment.
hello, hi, I'm
Hello.
from Sweden and SLU, and I work with the Swedish monitoring program for small agricultural streams, and we see that the nitrogen concentrations are increasing, although the farmers has done a lot of measures to reduce the losses, and it was a decline until like for 10 years ago, and then now it's steady or rising, and we assume that that could be a climate effect, but we're not sure. Thank you.
Thank you for your comment. And I see we also have a comment in the chat box from Tapio. It says irrigation can also maintain yield and nutrient uptake in dry seasons and decrease leaching. Would you like to say something more about that?
Yes, I just wanted to remind that there is also this positive effect on irrigation, so that when we are fertilizing in spring, we can take the nutrients off from the field and they are not left there due to the drought and dry yields.
Thank you. And if we don't have any more questions right now, I think we will say big thank you to Tia. Thank you so much for your presentation. And we will move on then to Tapio Salo from Finland, and you can show your presentation.
Okay, I guess now the presentation is visible.
Yes, we can see it. Well.
Yes, and I will tell you about from small literature study that was done in project funded by the Finland's Ministry of Foreign Affairs. It was called Baltic Sea Cooperation for Climate Resilience, and flood and drought risk management was the topic of the survey. In the end of the presentation, there will be a link, or at least you can get from the presentation, most probably shared later, the link for other reports on study on this work. I was also participating in the WaterDrive project, so that was my link for WaterDrive and this community also. And this literature study, it was done in Luke Natural Resources Institute by me and Merja Myllys and Pekka Parkkila from Center for Economic Development and Transport and the Environment was coordinating and also taking part of the those communal water related issues of the report. But let's go further. Let's see where I can find or can change the slide. So here, okay, first two illustrations about the problems that drought can cause for agricultural production. These are from my experiments where I was involved, and on the left we have the worst possible case caused by drought First, we had 2 moist seeding season, early spring, and after that, when we had got the seed into the moist and little bit compacted soil, the hard drought period started, and practically there are no plants coming from the soil, and result is a complete failure of production. And on the right picture, we can see the effect of drought on bit better field, where there are still rather sparse plant stands, and all the history of the field can be seen. Old open drainage, subdrains. If there are some compacted lanes on the field, those all are suffering from drought, and we got maybe 30–40% of the normal yield on that field on last summer. So the effects of drought can be very hard for farming. So first, short list, familiar for most of you, I guess. The effect of drought for agriculture: when transpiration decreases, growth and yield will decrease. This will lead less nutrient uptake, nutrient balances will increase, and the leaching will also increase, as there will be nitrogen and phosphorus left in the soil, not taken by the plants, and runoff will then take part of it to the rivers. And when high temperatures are often connected to drought, this will the growth development will be faster, and that also often leads to lower yields. In some soil types, wind erosion can take soil particles with it when there is a poor crop cover. Drinking water for animals can become scarce in some cases, and also quality risks become possible when the water flow in rivers is smaller. And due to the low yield, shortage of animal fodder will happen, and this can force farmers to make slaughterings that would not be planned. And communal water supplier, they might also have to restrict use of water. And Tia already showed nicely the effects of climate change. Just to take up some points, this temperature increase will hasten the crop development, and transpiration will increase. Precipitation might increase, but the critical months for production can be affected in a negative way, so that in early spring there might be less water available for crop. And proportion of heavy precipitation can also increase, so that we are losing part of the precipitation as surface runoff. Irrigation capacity has remained low or even decreased in Baltic Sea region, as was shown also in Tia's presentation, that there was not much possible or not much irrigation happening in Estonia. And then investments for agricultural water management have also been low, and price of agricultural products has not favored investments for irrigation. I don't know if you see this one bar on the top of the screen, but I don't know how I could get it out from the presentation screen. Okay, then there is a spring wheat yield statistics from last 10 years as Baltic Sea region, and also as a country-wise, Finland is rather large area. We have different weather each year, and so the statistical yields are often balanced by drought problems in some regions and good seasons in other parts of the country. From different countries, we can see here that there is fluctuation, and then the specific year is actually 2018, when low yields were common for spring wheat in all Baltic Sea states, and we might remember this for the most severe drought case in recent years in all of the Baltic Sea countries. Then from theoretical background, we know several ways to adapt for drought periods. We can work with soil management, we can reduce tillage and have less evaporation. We can keep up or increase soil organic matter that retains well water. Groundwater level regulation, for example, with controlled drainage is an option. And if we have an option to cultivate different soil types, we can secure good production in dry seasons for organic soils like peatlands that on the other hand are now under restrictions due to the climate change mitigation issues. Crop selection, species and cultivars that develop fast and deep root systems and winter crops are also a good chance to adapt for drought, as they start growth very early in spring when there is still plenty of moisture available in soil. Then irrigation, of course, we would then need only water resources, select a suitable machinery and method, and then be certain out of the economical feasibility of irrigation and animal production that have a long chain of events. If the number of cattle, for example, has to be decreased to the one dry season, it has a long-term effect on production of the animal farm. What kind of water reserves are available? Natural resources, lakes, rivers, ponds, groundwater, some cases, and the discussion or chances of constructed reservoirs that were also mentioned in Tia's talk. Communal water, it can affect drinking water for animals, as at least in Finland, in many farms, the drinking water comes from communal sources to guarantee the quality. And if there will be regulations, it can also affect for the farm. So the reaction of Baltic Sea states in recent years for severe drought that I collected many from websites and reports given from the issue. Often irrigation procedures have made easier in Baltic Sea states, but communal water service has had to regulate the use of water in some cases. And in the farms, losses due to drought, they have partially been compensated. And in case of animal fodder, green fallows, and other fodder sources that are not usually harvested, they can be used also in dry seasons for animal fodder. And then some selected examples from adaptation measures in Baltic Sea states. So different kind of instructions for irrigation systems, and have been created in most countries. In Finland, we have had a subsidy system for controlled drainage and drainage irrigation systems, and the availability and demand of irrigation water, there should be monitoring systems available to help decision making for irrigation. In Sweden, there is a service for estimating water availability. SLU has been active or making several studies to estimate economy of irrigating cereals and grasslands that have commonly considered not profitable to irrigate in our conditions. Irrigation pond planning has got instructions. In Denmark, they have a nice service for estimating the effects of climate change, and SEGES has been active in advisory services and has created a water accounts online service. Seawater can be used with certain conditions for irrigation also. Germany, reduced tillage, crop selection, wind erosion, keeping the crop residues on the soil surface can be prevented. Agroforestry has been considered as one option, and discussion has been going on for drought insurances if they would be feasible for farmers to make the production more safe for dry seasons. Then in Poland and Baltic Sea states, there were instructions for Global Water Partnership Project. The links and the material there can be later checked from the links. And in WaterDrive project, there was work going on in Kutna catchment, how to develop fields, how to develop drainage systems, and also plan the irrigation systems for the area. Then finally, a few slides from how the society should or could probably hopefully support the agricultural drought management. I think we should make system analysis to understand the effectiveness of methods that are related to soil management, crop breeding, and crop selection, how they would work in different regions and on different soil types. Then the studies on economy of irrigation with wide selection of crops that has been launched in SLU is something that we would need in other countries also, and the watershed level planning for getting water stored during the high runoff periods, and this would need investments to irrigation systems, as the statistics from Eurostat show that the proportion of agricultural land that is possible to irrigate is rather low in all Baltic Sea states, and it has been constant or even decreased, at least in the statistics in Denmark. And here is one slide to show the effect of soil type in dry seasons. The organic soils can maintain higher moisture and water supply in dry seasons, and there is maybe something like 10–15% higher yields in statistics compared to the clay soils. And then irrigation scheduling for watershed drought warnings, the system that is already used in some Baltic Sea states, and the instructions for irrigation permits, it should be clear for the farmers when they are able and how they can use the water sources for irrigation. Treated wastewater and other alternative sources, they can be an option in some cases, but hopefully, or I'm not myself very much interested for these chances, and I hope that we can still rely on natural waters in this Baltic Sea region cases. And finally, some links about this project that was used funding for this literature study, and you can later check those links from the shared presentations. Thank you from my part.
Thank you so much for this presentation. Really interesting. Now we'll see if we have any questions or comments. I have a question. Maybe I can start actually. So you mentioned some of the different projects and measures that are taking place in different countries. But I was wondering a little bit about how if you see any areas or specific measures that you see that the countries could work together around. Is there any specific like collaboration to tackle these challenges that you see would be beneficial?
Yeah, I guess those, let's say, like theoretical or the things that are based on soil management and maintaining soil organic matter, they are also similar in all Baltic Sea countries, I think. So a joint work for making a review article or review report to it would combine the experts from all Baltic Sea states. I see that the things are common for most of us here, and also the economy of irrigation, as thanks to the European Union, the basic economy of farming is rather similar. So I would not I would think that the work that has at least been going on in SLU could be well distributed and evaluated in other states also. Yes.
Thank you. Now we have a question from Omran.
Yes, yes. Thank you for the presentation. I have a question. I saw from your presentation that there is many advantages from irrigation in Finland, but why the farmers they don't invest? It's an economical issue, it's practical issue, or why they don't do irrigation?
Yeah, I guess it's mostly economical issue. In 1980s, it was much more common for cereal farmers and grassland farmers also irrigate, and they had those old style irrigation systems in use. But then after joining the European Union and the economical system changed from paying for production to the aerial subsidies, how much you cultivate hectares, it started to decrease the amount of or the areas irrigated. And I think that the economy is the basic reason for having so little irrigation. The vegetable farmers, potato farmers, sometimes also grassland farmers still irrigate in order to maintain grass yields for their cattle, but I think the economy should be somehow get better.
Then the economical issue comes from policy at high level, or you have to change policy at high level to affect the economy and change the situation for the farmers.
Yes, yeah, it's of course the prices are decided by the world markets, but then of course when aiming for high yields, it can become feasible for farmer also to invest the equipment and work for irrigation. So of course there is probably constant working on thinking on for the farmers when there could be a point to start the irrigation again in some cases.
Thank you.
I see we have another hand up.
Yes.
Please go ahead.
Yes, this is a so relevant topic that I can't stay quiet. Similar as we have already studied from before, there is a very detailed information needed to find the best locations for the best measures in terms of water and nutrient retention. And it seems to me that if these drought conditions will continue, then there will be a need to switch from water and nutrient retention measures to finding best locations for irrigation as well, since not all land parcels are suitable for this measure. And it seems to me that in some project call, this might be relevant also to study in Nordic and also Baltic countries to find suitable locations for this one. Thanks.
Yes, I agree with this comment of Ainis.
And I see we had a comment in the chat as well from Kaya. The effect of drought, also the CO2 emissions increase. Something to keep in mind. I don't know if the person wants to elaborate on that, then you can raise your hand. We have another hand up here from Navid. Please go ahead.
Yes, hi, and thank you very much for this webinar. This is very, very interesting to me. I'm also working with Pekka Parkila, actually, that Tapio has had a cooperation, I think, about finding the most appropriate place to locate the storages. So we are actually thinking about different methodologies. We got to the idea of using accumulation runoff maps to find out which place has the more runoff, and then if it's suitable, then we can use it as like with other criteria and then choose that place. So do you have any idea about that accumulation map data sets? And do you think that if it's a good idea if we choose that method? Thank you, anyway.
Yeah, personally, I'm not familiar with this mapping. There might be some colleagues on the audience who could help you and probably can reply to the chat if they know this system. I guess one point to think for those reservoirs is that it would be excellent to have some natural landscape, so that you should do as little construction work as possible, as it will of course increase the investment, and also of course then the land ownership and the ideas of farmers, where is the proper sometimes field to be sacrificed for irrigation pond is also a question.
Maybe we can have that as a shout out to the audience to see if anyone knows of any of those methods or materials that they can share. Please share in the chat or email us. Maybe we can do that. Thank you so much for your comment. I'm thinking, do we have another comment or question before we go for a break? I can't see anything.
Yeah, Katarina.
Katarina,
Yeah.
Yes, please go ahead.
Yeah, this with the need for maps for localization of which land to set aside for natural vegetation, where to irrigate, and where to the need for different crops. I just have a question from a municipality on this with mapping, because And my answer is, we don't have much information on how you decide on a certain location. We have the clay content, and we have soils in the subsoil, but then there is a need for maps on organic matter content, for drainage conditions, and so on. So it's a large need for this mapping. So just a comment. And I would also like to thank the two previous speakers. It was very nice presentations, both of them.
Thank you so much. Maybe that's also something that we can take with us, that it's a large and critical need to develop that kind of data and those kind of maps. Thank you so much. And thank you so much for your presentation, Tapio. So now we will take a break. It's always, I think there's always a big need to have breaks when you sit in front of a computer in these kind of digital meetings to get a leg stretcher. So let's do that. We will now, the time is 4 minutes past 10. So let's have a 11-minute break. So we'll meet again at 10:15. So 10:15 we will be back here, and then we will have a presentation from SLU and Sara Bergek. So please be back at 10:15.
Okay.
Then please go ahead.
Hi, thank you. You see the screen, right?
Yes, we see it on a full
Perfect.
screen. It's perfect.
Then I continue. So thanks. Let's see if I can change slide though. Don't want to go to the next slide. That was strange.
Does it
I don't
make
want
a difference if you share your window or the whole screen?
I can try to do the window instead of screen. Let's see. Let's try again. Yeah, that worked. Thanks, Christina. So yeah, thank you. My name is Sara and work at SLU and the Department of Aquatic Resources.
Oh, wait, now we just see we don't see the full screen.
I see it's full screen here. That's strange.
Maybe it's lagging.
Yes.
No.
Maybe you can try to share the whole screen again, not only the presentation itself.
Yes, I tried both now. It seems to. Let's see.
Sometimes it's working on second try.
Yeah. Or what you say, like the third time things
Yeah.
works. Let's see what happens. I'll try again. So maybe we have to do a third time, but I try again. Second time. Oh, this is the third time, so maybe. All right, let's see if it wants. Is it a full screen now?
Yes.
Yes.
Try
And I
to-
can change.
Yes.
Okay.
Yes, great.
Good. So third time. It takes 3 times. All right. Yes. So my name is Sara, and I want to just say a few words of this work I've been doing last years within the project Rich Waters. And Christina mentioned it in the beginning of the meeting, but also it's a few words what it is about for those of you that doesn't know about it. So it's the first live EP project in Sweden and started 2017. And so it's almost like half time now, 2024, it's ending. It's a fairly large project, but it is 30 million euro from EU, Swedish Marine and Water Agency, and also from the partners. And the goal is to implement the EU's Water Framework Directive and to speed up the implementation, basically, and improve the aquatic environment. And yes, it's a big project and many partners are involved. The county administrative board in Västmanland that is coordinating the project. And there's other municipalities and county administrative boards and companies and so forth, and also at the university. And 35 partners in all involved. And it's gathering through around 5 different themes that should create new knowledge and better methods. And these are better water planning, reduce eutrophication from agriculture, sewage and stormwater, reduce eutrophication from internal load, and measures for migration routes for fish. And also the 5th theme is decrease the amount of pollutants. And the part I've been involved in is part of a bigger project that is dealing with methods to identify areas where water can be channeled during floods, high floods. And it's 4 different parts where we are doing this work together with the County Administrative Board of Västmanland and Stockholm and Västra Götalands län. And we are dealing with identifying potential overflow areas and investigating risks related to flooding of contaminated areas. And the part that I'm basically more into is the water-related ecosystem services, both identification and assessment today, and what do we see in the future regarding flooding and climate change. And a 4th area is conditions and obstacles to success with different measures. So I will go a bit further into this part than I've been involved in. So just background overall, as you all know, the ecosystem in freshwater is highly affected by humans. We are have increased different kind of land use and overexplosion of different areas. We have the spread of invasive species, pollutions, environmental toxins and diseases, etc. And globally, 85% of wetlands are greatly affected by human activities. And this leads to a loss of biodiversity and also other ecosystem services. So, and above, also adding on different pressure, even than just by humans, we also have climate change. As we have talked about, we have a higher risk for both drought and also heavier rainfall and flooding. And changing climate is likely to be one of the most influencing factors on the biodiversity in freshwaters. And also the effect can be particularly high if it interacts with the other impacts and pressures that I just mentioned. So we have been looking into different parts and mainly into the risk of flooding and heavier rainfall in the future, and how ecosystem services in freshwater are affected, specifically by floods. And we have been doing this study in 2 catchment areas, Arbogaåns and Bällstaåns catchment area. The one to the left is Arbogaån, and it's running mostly in the forest in the northern part and going down in more agricultural land in the southern part. And as a comparison, we have the Bällstaån, which is in a city or an urban area, and is straightened and heavily affected by different pollutants in the water. So these are 2 different areas indeed. So we wanted to address these questions in in these different areas. And I will go into these 5 steps that basically we've been working according to. We have been working with identification of ecosystem services and assessment of ecosystem services today, what it looks like, and then going into analyzing then what happens in the future regarding flooding and climate change. And then adding on this knowledge in step 3 in step 4, in step 2 basically. So what happens with the assessment of the status of ecosystem services today when we have the flooding. And we are also working with where in the landscape should we place different kind of measures for maximum benefit of ecosystem and ecosystem services. But I will go through this briefly. In the first step, we have been working a lot with local knowledge, and we have been having lots of workshops around these areas. First, we together with local knowledge, municipalities and county municipal boards and companies and so forth, we have been identifying important ecosystem services in these areas, and also if they are, we think they might be also sensitive to flooding in the future. In step 2, I have been doing an assessment of the ecosystem services today, and I won't go that much into the detail how this is done. There is a report, and you can contact me if you want to hear more about it later on. But we have to the left the assessment of Arbogaån, and these are all different kind of ecosystem services that are existing in the freshwater in Sweden. And we've been using the Water Framework Directive and the classifications to to represent the status or the assessment of the ecosystem services today. A few other indicators we have been using as well, but yes, I can go into that later if you want to hear more. But the Arbogaån is most of the ecosystem services are from moderate to insufficient, and to the right we have Bellstaån, and as you see, it's more of an insufficient and poor status of the ecosystem services today. So how are ecosystem services effective by flooding? We have been looking into land and land use, and it depends on what land that gets flooded, of course, what happens in the water. We might have contaminated areas and decrease leakage of toxic areas and subsistence. We also have urban environment, maybe agricultural land. We talked about this as well. The spread of different subsistence and lead to eutrophication. And maybe also in the forest, and the effect might be different as well. So we have been using a sort of a flow chart, starting with the different kind of land uses in these areas, and the land uses that will get flooded during a 100-year rain. So these figures to the left and to the right are amount of land that get flooded according to 100 years rain. And we have been using this, going into these different kind of land uses, and the ones that are getting affected, projecting what happens, what is the risk of release of different kind of substances, such as nitrogen, phosphorus, sediment, or toxic substances. Then we continued with these substances and assessed how these affect ecosystem services in the water. So we added on that result to the assessment in today's climate, and we have done this for the ecosystem services that we identified with the local knowledge and local expertise that they wanted to look into further, that is very important in these areas. And to the left again, we have Arboga catchment area, and we have seen that both biodiversity, habitat regulation, eutrophication, and drinking water might be having a negative effect on the flooding. So the assessment of the status of the ecosystem services will get decreased. And for Bellstone, we have, as you see, a very bad, poor status today. So it's going to be even worse, adding on the effect of flooding and the spread of different substance area. And then we also have been using lots of workshop and local knowledge and discussed how to sort of add on different kinds of to maximize the effect of different measures in terms of on the ecosystem and ecosystem services. And this we've been doing in different ways. And I thought we would actually have some sort of interactive part now when we can talk about this a bit together and looking into what kind of measures we can do in the landscape. And now we've been focusing on the effect of, to reduce the effect of high floods. But as we talked also earlier, we also want to have water for irrigation, and we want to also have good habitat and etc. So we need to sort of think in many aspects to have the best localization of a measure. So I thought I'd just show this one. And for example, as in this figure, we might have a city down here that might be have a risk of flooded, and we can have a risk of the spread of different toxic substances and etc. And discuss then different kind of measures you can do up in the landscape to reduce the risk of flooding in the city. So I thought we can open this Menti that Kristina, so I hand over to you and you show your with your slide.
Yes. So I will then share my screen.
Yeah.
And I hope you can see the Menti now, the question.
Exactly. So then I just want you to pick or write a possible measure in the landscape. And the effect, an effect of that, I mean, the measure should be for a flow reducing effect, but also what other effects, positive effects, might that measure have for other parts in the ecosystem. So you can just enter like 3 words there, and we sum up while the answers are dropping in.
And you then need to go to menti.com and use the code that you see on the slide. So this is a different code than we used at the beginning of the webinar. So this code is 9616048.
So add a measure that you start to think about when you see this picture of the landscape, and in terms of flow reducing effect, but also maximizing maybe irrigation, as we talked about as well. If you discuss a bit on that.
Let
I
us
see a
know if you have
black
any
screen.
problems.
Sorry,
Oh,
I
black
see a black
screen.
screen. I don't know if you others see, but for me it's black.
Ah,
Oh, that's not good.
yes,
Let's see.
I saw
I
it.
can.
Yes.
I will share my screen again. I will. You're sharing, it says. I'm gonna do it again. Can you see it now?
I see it in there, at least.
You can also see it, yes.
Okay, great. Then maybe it's something else that is
Mm.
probably.
Yes, I don't see, but if everyone else sees it, it's okay. Can you repeat the code?
Yes, the code is 961604448.
I also
think-
copied the code in the chat room, so you can also copy it from there.
Thank you very much.
And maybe Sarah, you can read what
Yes,
the answers that are coming in here.
very quickly. So restoration of wetlands, one thing, so that it can lead to water retention, biodiversity, and nutrient retention, CO2 sequestration, buffer stripes, dedicated flooding areas, retention of nutrients and pollutants. To construct a wetland that absorbs the extra nutrient, provide ecosystem services, lake restoration, increase coastline, synchronization of runoff. It moves, so it's I don't have the time to read some of them disappearing. No black soils. Yes, lots of good things are dropping in and good suggestions. Can you scroll up, Christina?
Yeah, I'm pressing enter sometimes to stop.
Oh yeah, yeah.
And then it keeps scrolling.
All right, yeah.
extra function here.
Yes.
I didn't know of.
But good, I think it's lots of good things that are dropping in. Controlled drainage would have only water retention effect, however, it needed to reduce the risk of downstream, I think, flooding. Sad. Yes, this was just sort of an exercise to think about what measures we should use to have the maximum effect. We might have to think in many different ways and not only for one goal in terms of decreased risk of flooding. So we have been looking into this a bit, and we also have added on some discussion with local knowledge regarding constraints and what we have, and so social economic constraints and so forth as well, that might add on even more things to think about when you are implementing measures. High roughness of agricultural land, decrease of erosion as surface runoff decrease and infiltration increases. Yes. Good, thanks a lot for all the comments. It keeps on dropping in. And this is one area that we are continue to working on also in the project, because how to add on these different parts together. So I will save this, all the comments, or Christina saves it for me, and we will also add it on to our knowledge base and into the further work in the project. Okay, Christina, I think the time, right, are running. I should wrap up maybe.
Yes, and I can
Yes.
say that if you have anything else you want to type in or to add, you can just the question is open still. So even though I stop sharing, you can finish your what you're writing.
Yes, really good. It was a great expertise in this group, so it's really good to have your thoughts from here as well. So thanks a lot. I can just say some. You can just contact me if you want to read more. I have some reports. It's mainly in Swedish though, but if you want to hear more, we can talk later on as well, so you can get some more information. And Carina,
you can take 5 more minutes if you want to share your last slides.
Okay, good. Then I'll do that.
Go ahead.
Yes, great. Then I'll see if I can share it again. So just to sum up a bit where we are now in the project is that just what soil and substances that are leaking is important knowledge to assess the impact and minimize effects of flooding. And in these studied areas that we looked into, it seemed to be a negative effect on many ecosystem services and many supporting ecosystem services such as biodiversity and habitat. And these are also the base for many other ecosystem services. So it's adding on negative effect in the whole ecosystem.
Now we see the picture of the landscape.
It's really strange with the. Do you see now
with
when
conclusions? Yeah,
maybe
it's
I
not
keep
it
in this
full screen, but it works.
I keep it in this way, then you see it. Yeah,
Perfect.
Good. And it depends on, of course, on the soil type. I mean, or land type. It can be also positive effects in other areas, given there's another land type and less maybe pollutant areas. And we have to have sort of this landscape mindset when planning to take care of flooding and to think multifunctionality, as we were discussing a bit early now, to maximum the benefit. And I mean, the line, if you say so, the line between water and land is blurred in the future. So we have to also think not only what we do in the water and not what we do in the land, but connected and what happens, because also when we have the drought and the flooding, the line between the water and the land is actually erased a bit as well. So to have a greater mindset. So even more studies would be good, and methodological developments, and also to add on other aspects of climate change, such as drought, evaporation, and the temperature increases, etc. Yes, and there was a few reports that we have produced so far that you can contact me if you want to read more or hear more about. And here's also my contacts if you need to have questions afterwards. But thanks so far. We might have time for a few questions now. Let's see.
Yes, thank you, Sarah. Yes, we will take a few minutes for questions. If there are any questions from the participants to Sarah and what you've been working on. Maybe I can start with the question. I mean, you were mentioning a lot of different measures depending on context and where in the landscape you are to prevent degradation of freshwater ecosystem services. But can you name a few that are like key aspects or key measures to kind of summarize a bit? What do you think is most important to focus on? Because we saw that it was a lot of red.
Yes.
Red and poor status in the waters.
Yes, it's hard to say because it depends on where in the landscape and where we are. I mean, and if they're possible, if we have, for example, wetlands old wetlands that we can restore and to have as a buffer, etc. But it depends if we have that kind of areas. And also some just many small kind of measures might be good as well. in different parts of the area and not only focusing on one. So it's a hard question. It's a good question, but hard, because it depends, I would say, on where we are and what it looks like in the landscape.
Great, thank you. So if you have any questions, you can raise your hand, or you can just post the question in the chat. And I was thinking a little bit about the work you've done with different actors, where you've been going into communities and to discuss different ecosystems. What has been the how have people reacted to that? Are they very engaged, or what kind of attitudes did you meet?
Yeah, no, I would say very engaged. Of course, the municipalities, they want to know, how do we do this? So how do we actually, we can't do this with everything, sort of. It's, I mean, they have questions running every day with smaller questions if they can do, yeah, and they have to deal with. So so how do we do this? So to just think in this puzzle way that we did it in a more structured way at the workshops as well. So where you actually think of different parts and what the effects are was appreciated. And another thing is that just how we talk about ecosystem services. In the beginning of the year 2017, we had to start up to explain what it is. Now it's a pretty well established word, and people know about it, at least in Sweden, when we have the workshops.
I see, Tia, you raised your hand. You have a question or comment.
Maybe I missed the issue, but is there left any natural floodplains on your studied catchment areas?
No, there are not any that we haven't looked into specific floodplains, but there are old, and there are also existing around in the areas. But in our study, we don't have any direct measuring. We're not doing direct measures. We're just theoretically working around the questions, I would say.
Okay, thanks.
We have another hand. Ines.
Yes.
Go ahead.
Yes, thank you, Sarah, for your presentation. I was wondering, so you, I would like to say, started to evaluate different ecosystem services, but then so far as I can see, the evaluation was more on the comparable level. Either it's have a good effect on some aspects, or not so good, or not neutral.
Yeah.
But then the most challenging to my mind is to put some monetary value of these ecosystem services, and I can see that in future this will be the challenge that we will need to deal. Yes. And maybe you have already started something in this process.
No, that's really true. So we haven't a detailed study about the monetary values. We've been discussing that. So I mean, these measures, we want to do this. This would be the best, but is it even possible in terms of economical or structural, laws? And we have different parts that actually makes it possible, or even not possible, to do the stuff we want to do that is best for the ecosystem. So it's an interesting thing. We don't have it in the project as it is now, but we're definitely a good thing to continue on to study.
Great, thank you so much also for your questions. And thank you, Sarah, for your presentation and the interactive part as well. We will now move on to Ines, and you will present about the effects of extreme weather conditions on water quantity and quality in agriculture areas in Latvia. So please go ahead and share your presentation.
I hope you can see it now.
We can see it.
Great. So in this presentation, I will share the monitoring results that have been collected, analyzed, and showed in this presentation, which are collected as part of implementation of agricultural runoff monitoring program in Latvia, which is funded by the Ministry of Agriculture and also by the Rural Support Service. And I will add on in this presentation the light of WaterDrive in terms of what are the challenges we are dealing lately, and we will deal also in the future related to water quantity and quality. So I will refer to 2 years which happened to be one after another. And in 2017, we had a state of emergency in agricultural sector declared in 27 counties in Latvia, in 3 regions, or in part of these regions, where excess precipitation was taking place. And from that perspective, we saw that this might happen, and that it can be a lot of water coming from the sky and having direct effect on water quantity and also quality. And also we could see how this excess precipitation can result in also unharvested yields in fields, causing direct financial consequences to farmers, and also in terms of again in taxes in the national budget. And in one of our sites, we also had evidences of this excess precipitation, and this is in Malpīte research site, where you can see small catchment measurement structure, Krumpweer, where we measure water flow. And in this year, this structure was almost flooded. And we also took water samples at this time period, and also we had some samples from before and after. And we also could see how not only the quantity changes, but the quality as well. And then it caused also surface runoff. It was not only from the drainage systems that contribute to the drainage, but also surface runoff. And here you can see also, I think it is winter oilseed rape that has been planted. And even though we have this vegetation cover in the field, still surface runoff is taking place. And you can see that it is washing away soil particles and also organic matter from the field, causing again water quality consequences. And then what I can say that maybe can be assumed as a positive effect from this excess precipitation. So we could see the weakest points in our drainage systems, not only for the subsurface, but also for the surface. Drainage ditches, small rivers, culverts, some of those have been washed out. And from time to time, these type of events remind us that we need to take good care of the maintenance on a regular basis, not only then dealing with the consequences, which likely costs more than regular maintenance. And in this year, so we had these hydrologic measurements, and in this graph you can see discharge at this site for the whole year of 2017. First of all, I would like to pay your attention that what was also mentioned in Tia's presentation, that spring flood magnitude is decreasing, and you can see that it was much less in this year for this site, rather than we had these peak floods, flooding conditions also in the autumn of this year. And then the measure at the highest peak was 800 liters per second higher than the previous peak, which was measured in the spring flood in 2010. And 800 liters for such a small stream is a lot of water. And from this event also we can see that we might need to recalculate our design considerations for different hydrotechnic structures. For example, culverts, also the size of ditches and dimensions of ditches. And since we now saw that these structures can be almost flooded with increased precipitation rates. And in the next year, what that was also mentioned by Tapio, was drought in 2018, and these two consecutive years showed how different conditions in terms of moisture can be in agricultural areas in two back-to-back years. In this case, as you can see from the headline from the online newspaper, the drought in Western Latvia forced farmers to dispose of cattle. And also this was the first year when I heard the news that hay was stolen from one farmer as it was so deficit product at that time. And of course, this resulted also in lower yields for agricultural crops because of the moisture deficiency, also shown by Tapio in his presentation. And the same site, only 9 months later, you can see that water is not flowing over the crump year, and we don't have any flow at that point. And these two extreme conditions, so the highest measurement measured discharge and no discharge at all, was for the first time since we started measurements in 1995. So in more than 25 years of measurements, we had highest and the lowest water discharge at this site, showing how climate change effects might show in Latvia in specific region. And then, as I mentioned, the agricultural run-of-money program we carried out for water quantity and quality assessment, and to look for long-term trends of nutrient concentrations and losses in different spatial and temporal scales. And today I will present only results from 3 of our sites. You can see that these are located in central part and also in eastern and north east part. And the central part can be characterized as the most intensive agricultural areas with the warmest conditions and with the smallest amount of precipitation. And then Melpīt is somewhere in between Bērze and Vienziemīte, because at Vienziemīte site we have the coldest conditions and also the highest precipitation annually that has been recorded. And we have these studies in different spatial scales, but this time I will show the results from drainage field scale at these 3 sites, since these are the headwaters starting in agricultural areas. We are collecting water samples in drainage collectors and measure water flow also at this monitoring scale. And here you can see a nice map showing subsurface drainage systems in Melpīt site, a drainage field of 12 hectares and the small catchment of approximately 900 hectares in total area, with different land use, with more natural areas at the upstream part, and then agricultural areas with drained land in the central part. And then in this drainage field scale, we have only agricultural areas. Similarly, in Bērze site, you can see similar map with 2 scales of measurements, drainage field and also a small catchment with detailed mapping of subsurface drainage systems. Then I just wanted to show how it looks like, how we measure this discharge using Vīnočvier in this subsurface drainage systems, and by collecting these composite water samples based on flow. So when we come to results, you can see in this slide precipitation, average annual air temperature, and also drainage. We may call drainage also as runoff. And last 3 years of studies have been drier than the average, and also these 3 years were warmer than on average, showing that these patterns that was described by Tia is already present. These are not going to be happening somewhere in the future. And in this case, you can see that in 2017, we didn't have too much of the precipitation, somewhat higher runoff, but still it was not the highest value measured during the study period. And when we change for the Malupīte research site, here you can see that despite that we didn't have in 2017 the highest annual precipitation amount, still we have the highest runoff. And this shows us that it is very important to pay attention when the precipitation is taking place, the seasonal patterns. And in this case, precipitation was happening in September, October, November, when most of the precipitation was transformed directly to the runoff, as there were vegetation that could uptake it, and also what air temperatures were rather low to promote evapotranspiration rates as well. In this case, again, last 3 years somewhat drier than the average, and then also air temperature is higher than the average as well, but showing that in this case last 8 years were warmer than on average for the whole measurement period. And as I mentioned, in this site we measured not only in the small catchment scale, but also at drainage field scale, the highest and the lowest runoff in 2017 and 2018 respectively. And by turning to the last site, here maybe these trends are not so obvious. Still, one of years were above average in terms of precipitation, 2 years lower. But then in 2018, you can see that also the lowest runoff measured in the records was done in this year. And how this runoff precipitation, temperature, and runoff is related in terms of water quality, you can see from this graph. This is maybe from another site, but the trend is the same. So we have the highest concentrations of total nitrogen during the non-vegetation season, starting from October until the end of the March, beginning of April, and then in the summer season, this concentration decreases. So you can see how water flow directly affects the total nitrogen concentrations in agricultural areas. And it has to be mentioned that the nitrogen is the main form of the total nitrogen in agricultural areas, and it is approximately 85 to 90% of total nitrogen is in the form of nitrates. And just to change, I just wanted to show also the same hydrological behavior and how the concentrations of total phosphorus react. And you can see that here the situation is completely different than in case of total nitrogen. We have the highest concentrations measured during the vegetation season, when there are some episodes with maybe increased short-term runoff coming from the surface runoff events rather than from the drainage systems, because subsurface drainage systems start to stop to discharge water in the early summer, and then starts in early autumn. And from these two last slides, we can see that it is different how different nutrients correspond to the drainage events. And when we put together nutrient concentrations and discharge, so we can calculate mass load or losses characterizing a specific catchment area. And in this case, you can see that in Bears drainage field scale, the average loss is 18.4 kilograms per hectare for total nitrogen. And in 2017, it was higher than the average, but there are several years before where these losses were even higher. And you can see that less water caused also less losses in 2018. And this shows that if even farmers are doing what they have planned, then weather conditions may have the final word in terms of nutrient losses overall for the respective season or year. When we turn to Malupīte side, here the situation was more dramatic, as this excess precipitation was more evident in this research site. You can see that these losses were approximately 3 times higher in 2017 rather than on average. And then in the follow-up year in 2018, it was approximately twice less than on the average, showing that these weather patterns have great effect on the overall on the losses of total nitrogen. And finally, I would like to show you also the losses at vienzīmīte site, where we have a different crop rotation rather than at the Bears and Malupīte, where agricultural cash crops are grown. In case of vienzīmīte, we have permanent grasslands as dominant crop grown there, and you can see that these total nitrogen losses are approximately 3 times smaller than for both previous sites. And also from this slide, you can see that overall, from starting of the measurements until now, this trend is decreasing overall, even if we don't perform any statistical analysis. But even if we do, we can see the same, that there is statistically significant decreasing trend in nutrient in this total nitrogen loss for that site. In comparison for Bears and Malupīte, these trends are not statistically significant, since there are more changes in annual basis rather than in this case. And it all results in the consequences. If we lose more nutrients from agricultural lands and also from other sources, this results in excess eutrophication in the Baltic Sea. And I'm not sure if we have such a studies in the Baltic Sea region available, how the size of this hypoxic zone is changing as relevant to the nutrient losses from the previous year. But as I saw similar conditions and similar results from the Gulf of Mexico, where the Mississippi River discharges its water. So there, some studies have shown the direct correlation between nutrient losses from the year before and the size of hypoxic zone in the following year. And that would be interesting if we have similar for the Baltic Sea as well. But anyway, we have these evidences of from the 2018 in terms of growth of algae. It also could perform in such a, I would say, unique shape of this algae bloom, which was captured by the satellite in the Gulf of Finland in 2018, and also in 2018 we had this headline showing that algae blooms forced Poland to shut down 50 Baltic Sea beaches in the July of 2018, which again, to remind, was the year of dry and warm conditions in comparison with the previous year with excess precipitation. And then to conclude, still it shows us that we need to do more actions in direction of water management in agricultural areas. And if we would have more these water and nutrient retention measures, those could help us not only to retain nutrients, but also retain water, especially control drainage, and also some of other measures. And what we also try to promote in the WaterDrive project, that it is very important to increase the effectiveness in terms of nutrient retention, and also in terms of costs. We need to do it in the right thing, doing the right thing in the right place. And then what also was mentioned by Tapio today in his presentation, still land management is a very important aspects in terms of storing water in the field, increasing yields, and also reducing nutrient losses from agricultural areas. And here I basically had the same measures mentioned as we saw in Tapio's presentation. So with that, I would like to say thank you for your attention, and maybe we have still room for some questions.
Yes, thank you so much. It's really interesting. We do have some minutes for questions. I think it's important that we get a chance to discuss a little bit. I see one hand here. Omran, please go ahead. We can't hear you.
Yes, I'm sorry.
No,
thank you, Ines, for this interesting presentation. I would like to ask about the case of too much water, not to the drought, because in the previous presentation of Sarah, we saw that there is measures to prevent water from accumulation and flooding the downstream. But in your case, it's not the same. So the water is retained in the area, and it is flooded from the rainfall in the same area. It's not from the surrounding area. So I wonder about the measures that can be done to improve the drainage system in such flat area. I think it's flat, this area. So is there solutions or some insight for some measures to improve drainage?
Yes, thank you, Omran, for your question. So we have to keep in our minds that these drainage systems, either those are subsurface or those are ditches, they are designed to some certain probability of occurrence of precipitation. As Sarah mentioned, it's 100 years of flooding events. So these systems are designed to withstand somewhat less of precipitation. And there could be chances that even if we design those properly, those will still be flooded to if some major storm events come in. And I don't think that we need to extend this palette of measures that we are promoting during the WaterDrive project to some others. We just need to try to promote the implementations of these measures. And if we would have controlled drainage here and there, constructed wetlands here and there, so then the cumulative effect would provide the benefit we are looking for. And that also keeps us thinking about the in-field practices that also would provide their share in the reducing nutrient losses and also the water retention. So more implementation of these measures, and I think that that would be enough not to introducing some new ones.
Thank you. And I don't see any other question right now, so I will take the chance because a lot of change happens both from taking action and measures on local level, but we also do need the policymakers to be on board and make some changes. So could you maybe say something about what you think, like what would be your key message to policymakers? What do you want them to do?
I think I will not tell anything new now. We have seen a very good change in last couple of years. Since starting 2015, there was a funding available through Rural Support Service to maintain existing drainage systems, to renovate those and reconstruct. And in part of this renovation and reconstruction, there also was funding available for implementation of water and nutrient retention measures. And so my suggestion would be to continue to support these types of activities, even though in previous planning period, the implementation was not targeted at some specific areas where it would be maybe more necessary to implement these types of measures. But anyway, if we would have more of those, the cumulative effect would definitely be better. But to increase this targeted implementation of these measures, and it was partially done since if you required funding for renovation or reconstruction of drainage systems and your land was situated in the water bodies under the risk not to fulfill the Water Framework Directive water quality objectives, then you needed to mandatory to install these water and nutrient retention measures. And I think that was a very good decision to do that way, but still in these areas under the risk, we could do it more in a targeted implementation fashion rather than it was done before. But still, we are increasing our capacity and our knowledge about targeted implementation. And I can see that after this project, we will know more, and from university perspective, we will be more ready to provide some specific suggestions in terms of this targeted implementation.
Thank you. I was wondering if Tia, do you want to ask a question? I saw that you unmuted yourself.
Yeah. Thank you. Anissa, I just wanted to ask about this specific event. You just mentioned the 217 high precipitation event, this flooding. If I remember correctly, it has happened in autumn and September.
Yes,
right?
September, October.
Yeah.
Continued longer than only 1 month.
Yeah. But that's interesting that actually the high flooding in Estonia in 2017 took place in winter months, if I remember correctly, in January and February. But anyway, I wanted to ask the extent of this event. Was it very localized?
It was, yes, it was localized. I mentioned it. It was in 3 regions in Latvia and also in part of the regions. So it was not covering the whole territory at Latvia. And also from our measurement results, we saw that only in 1 site we had the direct impact from this event. In 2 sites there was almost no effect.
Okay, yeah, it sounds like.
So still it shows us that Latvia is a rather small territory overall, but we might have very dramatic changes and differences across the small country. And you can imagine how it could be in Finland or Sweden, it even more differences can take place in 1 year.
Yeah, it sounds very much like a kind of a convective precipitation event, which has happened pretty many times in Estonia also. So that, yeah, thanks.
Mm-hmm.
So thank you very much. I don't see any other hands. Yeah, now Stefan Lund has a question, I think.
Yeah. Hello, Ines. Thank you for your presentation and all the other presentations. Very nice. You showed this graph which showed a huge difference between arable land and land under grassland, permanent grassland, maybe. Do you have it's such a huge difference in nitrogen loading. Do you have any comments regarding how you would like to develop ideas concerning location of permanent grasslands, etc. in Latvia? It's a substantial difference in pollution load if you look at your diagram.
Definitely, Stefan. So this is a good example what the water quality could be if we turn our arable lands to permanent grassland. But then the main question is where we will put all the grass then. So it would be very easy to improve water quality. It would take like 3 to 5 years, cover all agricultural areas, and I would expect that water quality would dramatically increase, but economics does not support this type of change. And of course, extended crop rotation, maybe from time to time changing these, cash crops, yes, to permanent grassland, or to maybe some other kinds of crops like peas and beans and so on, that definitely would have a good effect, not only on nutrient losses, but also on soil health overall. But yes, the economics behind this is the main part why it's not possible to do it on a large extent. I just have to mention that in the Vienziemīte region, there is quite sandy soils and also quite steep slopes, so you can't grow regular crops over there, and this also can change that, can show us that there is also differences among regions in Latvia depending from soil conditions and soil fertility, where it is applicable to grow permanent grasslands and where maybe it's not so much.
And thank you, Hannes. And is there any financial support in Latvia for having permanent grasslands in the most sensitive areas? Do you have any such support?
Stefan, I'm not sure. I can't provide a specific answer to this question, especially since it's still in the process. As you may know, in all of our countries, until we will have the final cap ready.
Okay, thank you.
Thank you. Now I see we have one last question from Reynold. Please go ahead.
Yes, I think Stefan and Ines, we have in Germany, at least in Schleswig-Holstein, a specific situation with this huge amount of growing maize, of corn, and the problem, normally we have the situation that we have an early harvest, so we could establish a catch crop over winter, and I think having a catch crop over winter, we at least can store 40 to 60 kilo nitrogen in soil, not going eutrophying the water. But this year, the ripening process due to high temperature was so late that the harvest of maize for the biogas plants was very late. And it's the first year when I drive through landscape to Schleswig-Holstein, I can see a lot of black soils, because they haven't been able to establish a catch crop and to establish a crop over the winter. And the second point is, it's the first time that in very wet soil, farmers had plowed their areas, because we have now this root insect coming from the south to the north, and plowing is the only possibility to do something against this insect. So there's really during the last few years a dramatic change. On the other side, establishing 5 crops per farm, but on the other side, in monoculture with crop, that we have an increasing black soil area in winter, and that's very bad for eutrophication. So maybe in the southern countries of the Baltic Sea, this aspect might become also a tremendous factor in future years. Thank you.
Thank you, Reinhold. Just a very short comment. So main 2 crops in our landscape are winter wheat and the winter oilseed rape. So basically those are catch crops that try to grow also in the fall season. And from that perspective, I can see that these catch crops are feasible only for the spring areas that will be sown in spring for summer crops. So again, quite a lot of it, I would say, areas are already covered with cover crops from that point of view, that they are trying to uptake nitrogen and phosphorus in the soil.
Thank you so much for your comments and your contributions, and thank you so much for your presentation, Ainis. And now it's unfortunately time for us to round up a bit and close this webinar. And but first, I would like you to, as a last thing, I would like you to once again share a little bit about what your thoughts. Now you heard all these presentations. And just from your perspective, see what do you think is most important issues to focus on. So I will share my screen with the Mentimeter, and I will ask you to type in, to go to menti.com once again and use the code you see up here, 16906394, and to answer from your perspective and from what you heard today during these presentations on the topic of climate change and water and agriculture. What are the most important issues to address? And as I mentioned in the beginning of the webinar, I work together with colleagues in Life IP Rich Waters to not only implement the current project, but also to develop new projects. And we're also having a discussion with Staffan Lund, for example, from SLU, and thinking of what can we do in the future, and how can we find new collaborations. So I would love to get your input on what you think is most important issues to address. So please go ahead and type down your thoughts and your ideas and input. And I see that some of you already answered, which is great. And maybe we don't have much time to go through this right now, but I will take this with me for further discussions and thoughts. And I see that we have a lot of, as we talked about, like research and targeting assessment, for example, nutrient losses from agriculture areas. And here we also have an example of misinformation and speculation campaigns on social media to show farmers in a negative light. So there are a lot of different aspects, I think, here. And possible impact on climate change and agriculture production and dedicated areas. A lot for flooding in whole catchment. We've also been talking a bit about. And apply for common projects around the Baltic Sea, which I think is a great idea. We should do that more. So please go ahead and type in your ideas and your thoughts on what you think is most important issues to address. And I see there are some more about ecosystem services. One suggestion, for example. So I will keep this question open. You can, if you haven't written any reply yet, you can, you have some more time to do that. I will just change to my last slide and thank you all for contributing today in this webinar and this workshop. Thank you all speakers. And thank you all for participating. And if you want to know more about the projects, or if you want any specific information from the presentations, please go ahead and contact me. You have my email here, kristina.g.johansson@länsstyrelsen.se. So, or if you have any ideas for collaborations or anything you want to share, please go ahead and contact me. And I hope that we will hear from each other in the future as well. So thank you so much for today, and I hope I will see you again.